Right, so this is another chi-square distribution test. So we're still having that same test statistic in that it's going to show up as a chi-square, but what we're now going to be looking at is tests of independence. So we're going to be looking at contingency tables. So you remember contingency tables from probability? We have one here at the bottom of the screen where we have two pieces of information, and within our table, we have pieces of data or people sometimes that fit both of those pieces. So 111 people were community college students that worked 1 to 3 hours. So the question here is, are these two variables independent? In this case, the number of hours they work to the type of students that they are. And that's what we're ultimately going to be testing here. We're just going to go straight in to our example. I suppose I will read this last piece. In this test, the null and alternative hypotheses will be in words. With the two types of variables, the null is going to be that they are independent. The alternative is going to be that those two types are dependent. Right, but we'll always say what the two variables are. Like in this case, it's the type of student and the number of hours that they volunteer. All right, let's go in and write those down since we actually just said them. So we have this volunteer group, adults 21 and older, that volunteer from 1 to 9 hours each week to spend time with disabled senior citizens. The program recruits among community college students, four-year college students, and non-students. In the table below is the sample of the adult volunteers and the number of hours that they volunteer per week. So we have the type of volunteer on the left, community college, 4 years, non-students, and the number of hours that they volunteer. Again, the null is going to be that they are independent. The alternative is that they will be dependent. So our null in this case is going to be that the number of hours volunteered is independent of the type of volunteer. The order in which you write that doesn't matter. You could write the type of volunteer is independent of the number of hours that the volunteer volunteers. So you can switch before either of those, but again, the null is independent, the alternative is dependent. So we're just going to rewrite this and say the number of hours volunteered is dependent on the type of volunteer. All right, let's see by running a test of independence if this is significant enough to show or not. So we are going to use an online calculator to run this test, a different one. So not my goodness of fit. I'm going to go back to my whole laundry list and I'm going to go down to test for independence. That's what we're doing here. Test for independence. All right, note that this is much bigger than the table we have. Don't fill anything in, like don't put zeros in all the other boxes. Leave them blank if you don't need to use them. It's just a general calculator, so they give you more room than you often will need. We are putting in the order of our chart, what we have. So 111, 96, 91. This is going to take me a minute, so just bear with me. Maybe do it on your own. Now, I don't need to put in the column totals. So also note this. All right, that column total is not a fourth category. That's not a fourth variable. So I don't fill that in. All right, I move on and I put in 96, 133, 150. Don't put in the column total. Move on to the next one. 48, 61, 53. And I don't put in the row totals either, right? That's not its own variable. This is all the information I'm going to put in. Didn't fill anything into any of the others. I go to calculate and I have my test statistic, my chi-square, as well as my p-value. So chi-square, my test statistic, is 12.991 if we round it to 3 decimals. The p-value is 0.0113. We round to 4 values on that. This is our test statistic, 12.991, and our p-value was 0.0113. All right, our decision is based on the p-value compared to alpha. Now, did they give us an alpha here? Go up and see, did they say the level of significance anywhere? They didn't. When they don't give you a level of significance, we run it at 5%. 5% level of significance when 1 is not given. If they don't give you 1, you use a 5%. If they do give you 1, you use whatever they give you, right? Comparing digit by digit, we have zeros to start. 1's next, 1 and 5, sorry. So alpha is bigger than p. If the p is low, the null must go. So our decision is that we do indeed reject the null hypothesis, which is our H naught. Okay, so you either say reject H naught or reject the null hypothesis. Our conclusion, very similar to what it was in the past. At the 5% level of significance, because that's what we ran it at, level of significance, we have sufficient or insufficient? We have sufficient evidence. Okay, we did have the evidence to support our alternative. And our alternative hypothesis was that the number of hours volunteered and the type of volunteer are dependent variables. So we say to support that the number of hours volunteered and the type of volunteer are dependent on one another. Dependent, okay, on one another. Let's go ahead and do one more.